like to present to you our new design. In our new design, we eliminated all the holes around the bracket because they could cause stress while the material is being bending. The holes near the bend cause stress, so that's why we removed all the holes that also beside to the major hole, because in case of the drawing it will cause a fracture. Also, we made the edges smooth enough and round the corners to reduce stress. In the deep drawing features, we had 3-degree relief angle to avoid all fractures during bending the material and shearing it. We add a cut in the corner to reduce stress and avoid buckling and tearing. Remove holes from the upper of the bracket to reduce stress when it's being installed parallel to the ceiling, and bend is perpendicular to all directions to avoid fracture.
Our bracket production can be traced using a flow chart. We will receive the aluminum alloy sheet metal. We will then size it into squares, clip the corners to make notches in all 4 corners of the square. We will then shear the metal in half diagonally. This provides blanks for 2 brackets out of 1 square of metal. We will then deep draw the raised areas, and then the last step in the sheet metal working will be to bend at the edges. We will then go to the finishing stage where we will clean up the edges that we've cut, and we will anneal the bracket to relieve stresses. There are some numbers and equations that are valuable to know for the deep drawing. The aluminum alloy we're using has an R average of between 0.6 and 0.8, which means it has a limited drawing ratio of 2.2 to 2.5. The low R average means that we will have less earring on the deep draw. We can calculate an estimated force max, which equals pi times punch diameter times thickness times the limited drawing ratio minus 0.7. The thickness will be determined based on the strength requirements for the bracket, which can be discussed later in the design period.
We assume that the bracket is made from an aluminum alloy. Aluminum provides moderate strength and good ductility, so the ductility will allow for good forming of the sheet metal. Also, aluminum and aluminum alloy has good corrosion resistance. Typically, you put holes in structural parts for lightning. In this case, again, because we're using aluminum alloy, it's lightweight, so it doesn't need those lightning holes. After the bracket is formed with the features that have previously been described, we would anneal the bracket, and what that consists of is putting the bracket in the oven to get it up to just below the recrystallization temperature, and then leave it in there for a time, and then we would take it out and allow it to cool slowly. And that would tend to reduce the residual stresses.